Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome everyone to my channel again. This is episode 2 of solving trigonometric functions by applying product rule. And yeah, this is episode 2. So the first thing I want you guys to do is, if this is your first video that you're watching, make sure you copy the notes that I have on this page. So for every single episode, please expect that there's going to be a note like this at the front where you have like cheat notes. So for example, the first part of the note on the left side talks about sine x equals to 1 over cosecant x. Obviously, if you're using a different variable like p, it's going to be sine p equals to 1 over cosecant p. So what I'm trying to say is this first page is going to assist you when you're doing trigonometric function. It doesn't matter whether you are using product rule, chain rule, power rule, or even quotient rule. It doesn't matter. If you're not even doing derivative at all, this is going to be very helpful to you guys, inshallah, by God's grace. So yeah, let's start. So for this particular one, please copy this down if you don't have it. If you already are following the series, I believe you already have it in your notes. So let's start and go to the question that we have for today. So for this particular video, we have sine x, what f of x equals sine x multiplied by tan x, and we're supposed to apply the product rule to this. Now, the first thing we have to know is anytime we're going to apply product rule, we should remember the general formula of product of function that needs product rule. So it will be f of x equals to one subfunction, which is f of x, in this basically since it's general, multiplied by another subfunction, g of x. So since we're dealing with just two subfunctions, then we have f of x and g of x. Now these two subfunctions multiplied together gives us the entire function, which is the big F or capital F of x. So I just wanted you guys to know that first of all. So this is what the product rule what the product rule to be applied function to be applied, like we've not applied the product rule yet, to be applied function would look like two subfunctions multiplied by each other, or we can have three subfunctions or four subfunctions multiplied by each other, but for the purpose of this class, we're going to stick to two subfunctions multiplied by each other, just like we have sine x multiplied by tan x. Then when we apply product rule, we have d of dx of f of x equals to d of dx, so of f of x, so the derivative of the first function multiplied by the second subfunction, okay? So the derivative of the first subfunction multiplied by the second subfunction, then we have a plus the derivative of the second subfunction, which is g of x, multiplied by the first subfunction, which is f of x. That's literally what we need to do. When we do that, we have derivative of the first subfunction, f of x. That's basically, they're asking you to handle it. And in this particular case, before we start solving, we have to identify what f of x is in this case. Well, f of x in this particular question, let's go up top. F of x is going to be sine x. Since we're focusing on the position that we have, we're going to use the position of the general formula, which is basically this one. So G form is what general formula means. Using that, we know that f of x is going to be equal to sine x. And then we have g of x equals to tan x. Yay! So now that we've already identified it, we can start applying it. So here, I'm going to switch to a beautiful red color. So we have the derivative of the function. It's just going to be sine x multiplied by tan x. And that's going to be the derivative of f of x, which is going to be sine x, multiplied by g of x, which is tan x, plus the derivative of g of x, which is derivative of g of x basically, which in this case is derivative of tan x for this particular question, and then multiplied by the first subfunction, which we know to just be sine x. So now that we know that, now we can start like solution. So what's the derivative of sine x? Now remember the first page I explained to you the importance of having like the entire thing on your notes. And by the way, I apologize if I was fast when I went to the second slide. You guys can always pause the video whenever you want, of course, so that you can copy the notes in case you don't have it. So this is a trig law or trig functions, expression, identities, whatever you want to call it. Trig function notes to help you, at least for this series and hopefully future series as well, by God's grace, inshallah. So that's it. Derivative of sine x. That would be, what's the derivative of sine x? Well, derivative of sine x, we know that to be cosine x, which is right here, right? So in this case, we're going to put cosine x because that's what it is, right? Multiplied by, what is multiplied by tan x, right? Since we're not deriving tan x in this first part of the, before the plus sign, we already know we can just bring it down. This is just going to be brought down, and we're just going to put tan x here. It's just going to drop down. Nothing to do with it except bring it down. Just like when you have a constant value, right? And you're not multiplying the constant value or dividing it or adding it. It just comes down. So, yeah. Plus, just like if we had like 2 here, 2 just comes down. We're not doing anything with 2. So, derivative of tan x. What's the derivative of tan x? Now, let's go back to our first page. We know that tan x, derivative of tan x, we can see that to be secant square x. Okay, that's interesting. So we're going to put a secant, sorry, let's go back to red. We're going to put secant square x here. Then what is the last thing that we have when we put like that's going to be multiplied by sine x. Now, I want you guys to know this. For those of you students who might have seen it, but you're not really sure. Anytime in calculus when there's like a dot, the shaded dot is just indirectly telling you that that's a multiplication. So the dot that is in between sine x multiplied by tan x is just telling you that there's a multiplication. 2 things are multiplied by each other. Because this is calculus and we tend to use the variable x, using a cross sign to indicate or represent multiplication is not a smart move, because then students will be confused because there will be like multiple variables, multiple symbols. But if you put a dot sign, that's enough. Dot here does not mean decimal, it just literally means a multiplication. So yeah, that's really it. So let's go to the next page and continue with the solving here. So we have cosine of x tan x, right? Since that's what we're doing, plus secant square x sine x. So when we do that, we can leave our answer like this. We've actually done what is required of us, but as you guys know with my videos, if we're dealing with trig functions, I like to break it down into something a lot neater. So now that's when we can start applying some of the stuff again, or continue applying some of the stuff that I showed you guys at the beginning. So if you look at the beginning, what else can tan x represent? Tan x here can represent 1 over cotangent x, but cotangent x is not going to do much to what we have here. It doesn't make any sense, right? So what else can we do with tan x? We can say tan x is equals to cotangent x. It's not going to be of use here, but we know tan x is also equals to sine x over cosine x. And we can put that. And the reason why I'm going to do that, so sine x divided by cosine x, is because if I want my work neater, I want to find a way to cancel out the most amount of stuff so that we can just have very simple work to simple answer. Okay, very simple and neat answer. So that's that, plus secant square x. Yay, it's neat already, sine x. So our answer in this case here is sine x plus secant square x sine x. Now, we can also leave the answer like this. Like, remember what I said, this one here is perfectly alright. But if you want your work to be neater than mine, you can use it. So this is also an answer. This is an answer as well. But we also have sine x on both sides of the plus sign. So we can further factor out. And we can do sine x 1 plus secant square x. Now I'm satisfied that my work looks neat enough that I would want to make this my own answer. Now, if you guys decide to pick the first one, the second one, or this third one I just did, doesn't really matter. This is fine. I'm very sure that it's possible for people to play with it more. Like, you can play with it as much as you want and get different answers. But the truth is that all the answers, even though you can see different trig expression functions and all the other stuff jumbled up together, still all going to give you the same answer. Same answer. So yeah, my work is done. I prefer this answer that I just did to the very first one because it's neater and it's easier for you to see all that is going on compared to this very first one here at the top of the page where so much is going on. So now this is the end of this particular question. Please make sure you go to the description box because it has like the whole series, but you can also click on the series that is currently on the page right now. And yeah, just keep watching it and hopefully these videos are helpful. If you would like to subscribe, please subscribe. And if you would like to see more videos, put it in the suggestion box. Put it in the comment section or email me at shuhabeetutoring@gmail.com or habibah.t.dawodu@gmail.com. All my information, contact information and stuff that in case you need personal coaching or personal tutoring, all of that contact information is in the description. But my description box is basically a way for me to communicate with you guys. And if you want to keep watching the videos, there is a link to the series as well as on the page or on the video right now that you guys can use to keep on doing more of the problems, and inshallah you'll get used to it with time. So make sure you take care of yourself, and assalamu alaikum wa rahmatullahi wa barakatuh.